learning objectives. In this chapter, the user would learn the following aspects of raw material. Familiarize yourself with inventory management, know about EPA, get introduced to environmental and climatic conditions, familiarize yourself with bill of materials, get introduced to environmental and climatic changes. Components handling. As we have seen earlier, there are two types of components: active components and passive components. Active components need an external power supply. Passive components do not need an external power supply. Preventing electrostatic damage. Reduce the generation of static electricity. Dissipate safely any charges that have built up. Handle equipment correctly. Use protective devices. Handle equipment correctly. Do not touch components, solder runs or connectors on a PCB. Hold PCBs only by the edge and modules only by the handle if provided, or by the front panel. When disconnecting a module from a card cage type control during testing or service. Protective devices. Controls are sent from the factory with protective cars on cable receptacles. Leave the car on any receptacle that has no cable connected to it. Always install cars on all receptacles when a control is in storage. Preventing physical damage. Do not force a module when installing it into a control. If a module does not go into a control easily, check that the module is in the correct slot down. Be sure that the module is being inserted straight and that there are no bent pins or obstructions. Insert the module all the way in by hand before tightening the locking screws. Preventing electrical damage. Installation. When installing a control, double check to be sure that all system wiring is correct. Do not connect the control unit, all wiring is correct. Do not use the control to check the system wiring. Make sure that the wiring is correct before connecting it to the control. Testing and servicing. Do not make connections with power on. Double check all test equipment connections before applying power. Use battery operated test equipment whenever possible. Shipping. Unless otherwise stated in a product manual, preparing a device for shipment should be as follows. When a module or PCB is shipped separately, use a conductive PCB shunt bar on it if applicable and put it into an anti-static protective bag. Pack each module that is not installed in a control individually, each with a conductive PCB shunt bar if applicable, and each in its own anti-static protective bag. Use a non-abrasive material to protect all surfaces of the unit. Pack a complete control, a module or a PCB so that it has at least 100 mm. Storage. All controls, modules and PCBs that are to be stored in their shipping boxes with all protective devices in place. Store electronic equipment in a cool, dry place. Electronic store management. Retailing includes all activities in selling goods or services directly to final consumer. Characteristics. Direct indirection, customer service, more employment opportunities, different forms, sales promotion are different at this point only. Document management system. A document management system, DMS, is a computer system or a set of computer programs used to track and store electronic documents. It is usually also capable of keeping track of the different versions modified by different users. Components. The components are as follows: metadata, integration, capture, validation, indexing, storage, retrieval, security, workhow. Metadata. Metadata is typically stored for each document. Metadata may, for example, include the date the document was stored and the identity of the user storing it. The DMS may also extract metadata from the document automatically or prompt the user to add metadata. Integration. Many document management systems attempt to integrate document management directly into other applications so that users may retrieve existing documents directly from the document management system repository, make changes, and save the change document back to the repository as a new version, all without leaving the application. Capture. Capture primarily involves accepting and processing images of paper documents from scanners or multifunction printers. Optical character recognition (OCR) software is often used, whether integrated into the hardware or as standalone software in order to convert digital images into machine-readable text. Validation. Visual validation registration system and important data, for example, document failures, lack of bells, missing signatures, misspelled names. This can be printed on paper documents or images on paper. Storage. Store electronic documents. Storage of the documents often includes management of these same documents, where they are stored, for how long they are stored, migration of the documents from one storage media to another. Retrieval. Retrieve the electronic documents from the storage. Although the notion of retrieving a particular document is simple, retrieval in the electronic context can be quite complex and powerful. Simple retrieval of individual documents can be supported by allowing the user to specify the unique document identifier and having the system use the basic index. Security. Document security is vital in many document management applications. Compliance requirements for certain documents can be quite complex depending on the type of documents. Inventory management. Inventory management is a science primarily about specifying the shape and percentage of stocked goods. It is required at different locations within a facility or within many locations of a supply network to precede the regular and planned course of production. The scope and stock of materials of inventory management concerns the fine lines between replenishment lead time, carrying costs of inventory, asset management, inventory forecasting, inventory valuation, inventory visibility, future inventory price forecasting, physical inventory, available physical space for inventory, quality management, replenishment, returns and defective goods, and demand forecasting. Definition. Inventory management is primarily about specifying the size and placement of stocked goods. Inventory management is required at different locations within a facility or within multiple locations of a supply network to protect the regular and planned course of production against the random disturbance of running out of materials or goods. Business inventory. There are 4 main reasons for keeping stock. Time. The time lags present in the supply chain from supplier to user at every stage requires that you maintain certain amounts of inventory to use in this lead time. However, in practice, inventory is to be maintained for consumption during variations in lead time. Lead time itself can be addressed by ordering that many days in advance. Uncertainty. Inventories are maintained as buffers to meet uncertainties in demand, supply, and movement of goods. Economies of scale. Ideal condition of 1 unit at a time at a place where a user needs it, when he needs it principle tends to incur lots of costs in terms of logistics. So, bulk buying, movement, and storing brings in economies of scale, thus inventory. Appreciation in value. In some situations, some stock gains the required value when it is kept for some time to allow it to reach the desired standard for consumption or for production. For example, beer in the brewing industry. Terms. Stock keeping unit (SKU) is a unique combination of all the components that are assembled into the purchasable item. Therefore, any change in the packaging or product is a new SKU. Stock out means running out of the inventory of an SKU. New old stock is a term used in business to refer to merchandise being offered for sale that was manufactured long ago but that has never been used. Manufacturing. A canned food manufacturer's materials inventory includes the ingredients to form the foods to be canned, empty cans and their lid labels, and anything else that will form part of a finished can. The firm's work in process includes those materials from the time of release to the work floor until they become complete and ready for sale to wholesale or retail customers. This may be vats of prepared food, filled cans not yet labeled, or sub-assemblies of food components. It may also include finished cans that are not yet packaged into cartons or pallets. Its finished good inventory consists of all the filled and labeled cans of food in its warehouse that it has manufactured, and wishes to sell to food distributors, to grocery stores, and even perhaps to consumers through arrangements like factory stores and outlet centers. Purpose of inventory proportionality. Inventory proportionality is the goal of demand-driven inventory management. The primary optimal outcome is to have the same number of days worth of inventory on hand across all products so that the time of run out of all products would be simultaneous. In such a case, there is no excess inventory, that is, inventory that would be left over of another product when the first product runs out. Excess inventory is suboptimal because the money spent to obtain it could have been utilized better elsewhere. The secondary goal of inventory proportionality is inventory minimization. By integrating accurate demand forecasting with inventory management, rather than only looking at past averages, a much more accurate and optimal outcome is expected. Applications. The technique of inventory proportionality is most appropriate for inventories that remain unseen by the consumer, as opposed to keep full systems where a retail consumer would like to see full shelves of the product they are buying so as not to think they are buying something old, unwanted, or stale, and differentiated from the trigger point systems where product is reordered when it hits a certain level. Inventory proportionality is used effectively by just-in-time manufacturing processes and retail applications where the product is hidden from view. High-level inventory management. There was a change in manufacturing practice from companies with relatively homogeneous lines of products to horizontally integrated companies with unprecedented diversity in processes and products. Those companies attempted to achieve success through economies of scope, the gains of jointly producing 2 or more products in one facility. The managers now needed information on the effect of product mix decisions on overall profits and therefore needed accurate product cost information. A variety of attempts to achieve this were unsuccessful due to the huge overhead of the information processing of the time. High-level financial inventory has these 2 basic formulas which relate to the accounting period. Cost of beginning inventory at the start of the period plus inventory purchases within the period plus cost of production within the period is equal to cost of goods available. Cost of goods available minus cost of ending inventory at the end of the period is equal to cost of the goods sold. Accounting for inventory. Each country has its own rules about accounting for inventory that fit with their financial reporting rules. The internal costing or valuation of inventory can be complex. It is intentional that financial accounting uses standards that allow the public to compare firms' performances, cost accounting functions, internally to an organization and potentially with much greater flexibility. Financial accounting. Inventory appears as a current asset on an organization's balance sheet because the organization can, in principle, turn it into cash by selling it. Some organizations hold large inventories than their operations require in order inflating their apparent asset value and their perceived profitability. In addition to the money tied up by acquiring inventory, inventory also brings associated costs for warehouse space, for utilities, and for insurance to cover staff to handle and protect it from fire and other disasters, obsolescence, shrinkage, and others. Such holding costs can mount up between a third and a half of its acquisition value per year. Role. By helping the organization to make better decisions, the accountants can help the public sector to change in a very positive way that delivers increased value for taxpayers' investment. It can also help to incentivize progress and to ensure that reforms are sustainable and effective in the long term by ensuring that success is appropriately recognized in both the formal and informal reward systems of the organization. To say that they have a key role to play is an understatement. Finance is connected to most, if not all, of the key business processes within the organization. It should be steering the stewardship and accountability systems that ensure that the organization is conducting its business in an appropriate ethical manner. It is critical that these foundations are firmly laid. So often, they are the litmus test by which public confidence in the institution is either won or lost. Finance should also be providing the information, analysis, and advice to enable the organization's service managers to operate effectively. Inventory examples. Raw materials. Materials and components scheduled for use in making a product. Work in progress, WIP. Materials and components that have begun their transformation to finished goods. Finished goods. Goods ready for sale to customers. Goods for resale. Returned goods that are saleable. Stocks in transit. Consignment stocks. Stock rotation. Stock rotation is the practice of changing the way inventory is displayed on a regular basis. This is most commonly used in hospitality and retail, particularly where food products are sold. For example, in the case of supermarkets that a customer frequents on a regular basis, the customer may know exactly where they want and where it is. This results in many customers going straight to the product they seek and do not look at other items on sale. Inventory credit. Inventory credit refers to the use of stock or inventory as collateral to raise finance. Where banks may be reluctant to accept traditional collateral, for example in developing countries where land title may be lacking, inventory credit is a potentially important way of overcoming financial constraints. National accounts. Inventories also play an important role in national accounts and the analysis of the business cycle. Some short-term macroeconomic fluctuations are attributed to the inventory cycle. Purpose of inventory management software. Inventory management software is used for a variety of purposes including 1. Maintaining a balance between too much and too little inventory. 2. Tracking inventory as it is transported between locations. 3. Receiving items into a warehouse or other location. 4. Picking, packing and shipping items from a warehouse. 5. Keeping track of product sales and inventory levels. 6. Cutting down on product obsolescence and spoilage. Advantages. The following are the advantages: cost savings, increased efficiency, warehouse organization, data security. Disadvantages. The following are the disadvantages of inventory management: expense, complexity. Environmental protection. With the continuously growing population and pollution, the environment is getting affected to a great extent. This involves planning, protection, monitoring, assessing, educating, and conserving the major guiding factors for the nation's development. Knowing that environmental pollution is a worldwide problem, the need to protect environment from international to national levels is fast growing. EPA. EPA stands for Environmental Protection Agency. This is an agency of the US federal government. It was established on 2nd December 1970. The United States is playing a prominent role in working with other countries to protect the global environment. They accomplish this by writing laws and implement it by regulations. They not only set standards but also help organizations to understand the set standards. Goals of EPA. The goals of EPA are: reduce air pollution, improve access to clean and safe water, promote material management, waste management, and clean sites. Environmental Protection Act, 1986. After the Bhopal gas tragedy, the Government of India felt the need for an act in place to protect the people and the environment from such accidents. The objectives of the Environmental Protection Act is to implement the decision made at the UN conference that was held at Stockholm in June 1972 on human environment. The Act has provisions for penalties in case of offences committed. The Act authorizes the central government to protect and improve the quality of environment by controlling and reducing pollution from all sources, prohibiting or restricting the setting up or operation of any industrial facility on environmental grounds. The International Organization for Standardization provides a tool to help industries and organizations that are aiming at identifying and controlling environmental impact. ISO 14000 families from the international standards serve as one such tool. It provides a framework for industries and organizations to systematize and improve environmental management efforts. It starts with evaluating the effect an organization has on the environment. This will include the products, processes, and the wastage to be evaluated. With this data in hand, the management has to kickstart the process of working towards the aim of reducing the effect of such activities on the environment. Occupational health and safety standards. It is a known fact that employees working in various organizations are exposed to different kinds of danger because of the nature of their job. It is the responsibility of the organization that they work in to protect them from such dangers and provide them the necessary training and equipment to safeguard them. It is necessary that every employee has to be given awareness about these hazards and educated properly about the importance of safety before beginning to work. A standard that helps organizations to ensure occupational health and safety is OHSAS 18001. It is a British standard. All kinds of organizations can adopt this standard. It is the world's most widely recognized occupational health and safety system standard. This again is not a legislative requirement but can be taken up by organizations on a voluntary basis. Community health and safety. Health and safety of a community is influenced by places in which people live, learn, work or play. Communities like schools, public places and work sites can be maintained to support healthy living. We call a community a healthy and safe place to live in if it has clean air, pure water, safe housing and the necessary supportive structures like schools, hospitals, etc. In a family, the health and safety issues can be handled by careful usage of resources and by maintaining a clean living place. But when it comes to the health and safety of a community of people, various factors have been taken into consideration. Awareness and education. Awareness and education on environmental protection is necessary for us to understand how fragile our environment is and how it needs to be protected. It is a process that every human being on the earth should participate in to help create a better world for the generations to come. Awareness and education on environmental pollution alone will not be sufficient. We have to go one step further to educate people about the alternative methods that can be adopted that would not pollute the environment for transportation, lifestyle, and so on. Environmental education has to be given equal importance like other subjects in schools and colleges. Students, being building blocks of the years to come, need to understand the importance of environmental protection. E-waste in IT and electronics industries. Any used or obsolete electric device found in offices or homes is known as e-waste. 29.9 million desktop computers and 12 million laptops were discarded in 2007 according to the Environmental Protection Agency. Key takeaways. Here is a recap on what you have learned from this session. Environmental pollution affects not only individuals but countries also. Environmental protection means proper utilization, protection, conservation, control and recycling of resources that will help in maintaining a balanced ecosystem. Introduction. All of our lives, we have known that oxygen and air are the most precious resources to human beings. Human beings can survive for weeks or even months without food and for days without water. However, a few minutes without air threatens our whole life. Today, in the year 2050, air pollution is all around us and it continues to disturb the balance of nature and keeps on destroying the ecology of the world. Problems. This problem began during the Industrial Revolution, where changed agricultural and industrial practices created new chemical compositions, oil, coal, gas, carbon dioxide, and added gases that absorbed infrared radiation and were released into the atmosphere. In some places it didn't rain and the crops didn't grow. The hurricanes increased in intensity as a consequence of changes in climate. The water cycle that plays an important role in this natural process also was contaminated. It affected the vital cycle in the planet, changing the ecology of the earth. Consequences. They didn't protect the environment when they should have. The chemical composition and pollution in the atmosphere are destroying all life. The people suffer odd illnesses and new epidemics have appeared. Skin cancer has increased due to the depletion of the ozone layer. The children are being born deformed because of radiation, and more children die from severe diarrhea caused by dirty water. The ground doesn't give food, and the species of the sea and animals are dead due to acid rain. The natural resources are ending and people are beginning to die. Reasons. The conditions of life are poor, and poor countries are the first to feel this effect. People in these countries don't have enough food, and they live in holes and caverns trying to protect themselves from exposure to the rays of the sun. They leave their caverns in the night to collect whatever food they might find in the surface. In contrast, the rich countries with their superior technology create artificial food, water, air, and other resources to survive. They live in comfortable subways where people stay all the time trying to protect themselves from this change that happened in the atmosphere of the earth. As a consequence of global warming and ozone layer destruction, the changes in ecology and climate are exterminating our lives. Human beings, animals, and plants are suffering many changes and need to adapt. Climatic change. It is a significant and lasting change in the statistical distribution of weather patterns over periods ranging from decades to millions of years. It may be a change in average weather conditions or in the distribution of weather around the average conditions. Factors. Climate change is caused by factors such as biotic processes, variations in solar radiation received by Earth, plate tectonics, and volcanic eruptions. Terminology. The term sometimes is used to refer specifically to climate change caused by human activity as opposed to changes in climate that may have resulted as part of Earth's natural processes. Causes. Factors that can shape climate are called climate forcings or forcing mechanisms. These include processes such as variations in solar radiation, variations in the Earth's orbit, mountain building and continental drift, and changes in greenhouse gas concentrations. There are a variety of climate change feedbacks that can either amplify or diminish the initial forcing. Internal process. Internal processes of the climate system include natural changes in the components of Earth's climate system, and their interactions are the cause of internal climate variability. CO2 is considered a forcing of the climate system or can be used as a feedback when modeling climate. Bill of materials. A bill of materials, sometimes bill of material or BOM, is a list of the raw materials, subassemblies, intermediate assemblies, subcomponents, parts, and the quantities of each needed to manufacture an end product. A BOM may be used for communication between manufacturing partners or confined to a single manufacturing plant. A BOM can define products as they are designed, engineering bill of materials, as they are ordered, as they are built, or as they are maintained. Types of BOM. The different types of BOMs depend on the business need and use for which they are intended. In process industries, the BOM is also known as the formula, recipe, or ingredients list. In electronics, the BOM represents the list of components used on the printed wiring board or printed circuit board. Once the design of the circuit is completed, the BOM list is passed on to the PCB layout engineer as well as component engineer who will procure the components required for the design. Modular BOM. In many cases, BOMs are hierarchical in nature with the top level representing the finished product, which may be a subassembly or a completed item. BOMs that describe the subassemblies are referred to as modular BOMs. An example of this is the NAAMS BOM that is used in the automotive industry to list all the components in an assembly line. The structure of the NAAMS BOM is system, line, tool, unit, and detail. The first hierarchical databases were developed for automating bills of materials for manufacturing organizations in the early 1960s. At present, this BOM is used as a database to identify the many parts and their codes in automobile manufacturing companies. A bill of materials implosions link component pieces to a major assembly, while a bill of materials explosion breaks apart each assembly or subassembly into its component parts. Formats of modular BOM. A single level BOM that displays the assembly or subassembly with only one level of children. Thus, it displays the components directly needed to make the assembly or subassembly. An indented BOM that displays the highest level item closest to the left margin and the components used in that item indented more to the right. Modular planning BOM. Configurable BOM. A configurable bill of materials is a form of BOM used by industries that have multiple options and highly configurable products. For example, telecom systems, data center hardware PCs, autos. The CBOM is used to dynamically create end items that a company sells. The benefit of using CBOM structure is that it reduces the work effort needed to maintain product structures. The configurable BOM is most frequently driven by configurator software. However, it can be enabled manually. The development of the CBOM is dependent on having a modular BOM structure in place. The modular BOM structure provides the assemblies or subsystems that can be selected to configure an end item. While most configurators utilize top-down hierarchical rule syntax to find appropriate modular BOMs, maintenance of very similar BOMs becomes highly excessive. A newer approach utilizing a proprietary search engine scheme transversing through selectable components at high speeds eliminates the planning modular BOM duplications. BOM based on characteristics. The composition of a product can be represented using a directed acyclic graph called real structure, in which every node is an aggregation of its children nodes. The end nodes are called individual components. The intermediate nodes are called partial assemblies. The root node is the final product. The graph arcs show the quantities of child components required to create a single instance of the parent, whether the parent is a partial assembly or the final product. The graph representation can be more useful than a tree representation in cases where the same component type is used repeatedly in building different assemblies. The graph type can also be applied to a production process, in which case it is known as an ideal structure graph, in which each node represents a process step. The leaves of the graph correspond to a single step of the production process. The intermediate nodes represent a macro phase or a next step. The root of the graph represents the entire process. Characteristics to configurable the BOM. The product variations can be expressed using characteristics or features. Every product variation is defined by a combination of these characteristic values. If the considered product can have several variations, it can be too expensive to define each one of these with a different BOM structure. Using the technological structure and the characteristics, it is possible to define all the product variations in a single BOM structure simultaneously. It is sufficient to assign to the link between a real node and an ideal node a characteristics-based Boolean function, which we shall term the application function. The value of this function will be true only when the combination of the characteristic values correspond to a product variation where the real node is used effectively. BOM structure navigation. Given a product variation represented by a specific characteristic valorization, it is possible to dynamically obtain the BOM structure, navigating the technological structure and selecting only the real nodes having a true application function. Furthermore, linking each selected assembly with the real node selected in a subgraph, it is possible to dynamically build the real structure. It is similarly possible to obtain the composition of an assembly related to an ideal node. It is sufficient to visit the subgraph having as root the ideal node itself, excluding the starting real node siblings and selecting the real nodes which application function has a not empty intersection with the application function of the starting real node. It is moreover possible, given a real node, to obtain all the assemblies it can belong to. If it belongs to a real structure, it navigates the structure in bottom-up direction, All the encountered real nodes are composed by the starting real node. Then, for each encountered real node linked to an ideal node, it traces the application function f and visit in bottom-up direction the ideal structure. For each parent ideal node, all the real node related to it and having a not-empty application function intersection with f are then composed by the starting real node. Types of BOM. There are two types of BOM which are as follows: static fixed bill, dynamic parametric bill. Static fixed bill. A bill of material for a part that is normally made from the same components, labor and raw materials. Used for standard assemblies, components and engineered to order customer orders. Example: a bill of materials for a standard chair. Dynamic parametric bill. A bill of materials for a product or part for which size, color, laminate and other options can be selected. Example: a bill of materials for a Dell computer. Information on BOM. The following information on BOM is as follows: quantity, item ID number, description of item, cost of item, total project cost. Explanation. Quantity tells user how many of each part is needed for each project. Example: a chair needs 1 seat, 4 legs, 1 back and 5 nails. Item ID number tells us which part to order and can be any of the following: catalog number, UPC or any other identification number. Example: the chair needs a 2 PC seat, 5 DR legs, 6 TU8 back and 1 inch nails. Description of item provides a check that the correct item is being ordered. Cost of item. Cost is included to show how much each part is per item and that the total cost of all like parts. Example: the cost of a leg is $5 per leg. Then the total price of the legs ordered would be $20 because there are 4 legs. Total project cost shows the total cost of all items and is also the total cost of the direct materials used in the project. Example: seat $10, back $5, leg $5, nail $0.5 per nail. Total cost of a chair 10 plus 5 plus 5 into 4 plus 0.5 into 5, which is equal to $37.50. Uses of BOM. A BOM can also be visually represented by a product structure tree, although they are rarely used in the workplace. Life. Life affects climate through its role in the carbon cycles and such mechanisms as evapotranspiration, cloud formation and weathering. Ocean variability. The ocean is a fundamental part of the climate system. Some changes in it occurring at longer timescales than in the atmosphere, massing hundreds of times more and having very high thermal inertia. External forcing mechanism. The forcing mechanisms are human influences, orbital variations, solar output. Human influences. The scientific consensus on climate change is that climate is changing and that these changes are in large part caused by human activities. Orbital variations. Slight variations in Earth's orbit lead to changes in the seasonal distribution of sunlight reaching the Earth's surface and how it is distributed across the globe. Solar output. The sun is the predominant source of energy input to Earth. Both long and short-term variations in solar intensity are known to affect global climate. The Great Oxygenation Event, oxygenation of the atmosphere around 4 billion years ago, was the most notable alteration. Over the next 5 billion years, the sun's ultimate death as it becomes a red giant and then a white dwarf will have large-scale effects on climate, with the red giant phase possibly ending any life on Earth that survives until that time. Vegetation. A change in the type, distribution and coverage of vegetation may occur given a change in the climate. Some changes in climate may result in increased precipitation and warmth, resulting in improved plant growth and the subsequent sequestration of airborne CO2. Example of this occurred during the Carboniferous Rainforest Collapse, or CRC, an extinction event 300 million years ago. Precipitation. Climatological temperatures substantially affect precipitation. Similar slight overall increase in global river runoff and in average soil moisture has been perceived. Analysis of ice in a core drilled from an ice sheet, such as the Antarctic ice sheet, can be used to show a link between temperature and global sea level variations. The air trapped in bubbles in the ice can also reveal the CO2 variations of the atmosphere from the distant past, well before modern environmental influences. An ice core is a core sample that is typically removed from an ice sheet. The study of these ice cores has been a significant indicator of the changes in the CO2 over many millennia and continues to provide valuable information about the differences between ancient and modern atmospheric conditions. Animals. The historical abundance of various fish species has been found to have a substantial relationship with observed climatic conditions. Changes in the primary productivity of autotrophs in the ocean can affect marine food webs. Sea level change. Global sea level change for much of the last century has generally been estimated using tide gauge measurements collated over long periods of time to give a long-term average. Methods. General circulation models based on the physical sciences are often used in theoretical approaches. The approach to match past climate data, make future projections, and link causes and effects in climate change. Conclusion. In this chapter, the user has covered the following aspects of raw material: inventory management, EPA, environmental and climatic conditions, bill of materials, environmental and climatic changes.